These are the 5 things I wish I knew when I started out at ArcPy writing geoprocessing scripts quite a long time ago. First is the proper syntax. The second is the copy Python command that you can use in ArcGIS Pro, where you fill in your geoprocessing tool and you copy the syntax and you paste it into your script, saving quite a lot of time and useful for debugging. The third and most important is the result object that is returned from the geoprocessing tool when you use ArcPy. This saves a lot of time. The fourth is the memory workspace that you can use in tandem with the result object for really efficient coding in your scripts. And the last is environment settings that adds efficiencies and extra controls when you are using geoprocessing tools with ArcPy. So let's get started. We will start with the syntax. When you are creating a standalone script outside of ArcGIS Pro, up top you import ArcPy. This will allow us to access the ArcPy Geoprocessing tools from various toolboxes. For example, we would call ArcPy, and let's say we wanted to use the Table to Excel tool. We'd use dot. The Table to Excel tool sits in the Conversion toolbox, and the name of the tool is Table to Excel. We then use parentheses, and we can fill out the input to the parameters. Another common toolbox is the Data Management toolbox, where we'd call ArcPy.management. And then you might want to call the Add Field tool. One of the most popular tools in GIS is the Buffer tool. We could call ArcPy. The Buffer tool sits in the Analysis toolbox, and we call the Buffer tool, and then the parentheses. Now I highly recommend this convention when you are writing your Python scripts using ArcPy. This is the new convention that you'll see in all the Esri documentation. ArcPy dot, the name of the toolbox, dot, and the name of the tool. It is also recommended that you use the parameter names when you are calling the geoprocessing tool. For example, for buffer, we'd have our in features, and you'd set that to be your input layer or feature class. Then you'd set your out feature class to be the path to the output, and then you'd have the buffer distance or field, which might be 10 meters. I'm going to head over to the documentation for buffer tool in ArcGIS Pro. Here we have the Esri documentation for the buffer geoprocessing tool from the analysis toolbox. If I scroll down, I want to hit the parameters entry, and I want to click into the Python tab. And here we can see the syntax, arcpy.analysis.buffer. The parameters that have the curly braces are optional, and those that do not are required. Here we can see the 3 parameters that I set in the script: in features, out feature class, and the buffer distance or field. The Esri documentation is an excellent resource if you are looking for the syntax for the tool and the parameter names to use that are required or optional. If we scroll down, we will see some examples of geoprocessing tools being called. Here we can see arcpy.analysis.buffer, and we can see here that this Esri documentation does not use the parameter names. But the first 3 here would be the required parameters: the input features, the output feature class, and the distance or buffer field. But it's hard to know which parameters are being utilized from the optional parameters. In this example, we can also see the Erase tool being used from the Analysis toolbox. I'll head back over to the Python script, and we can see that this is much more easier to read than without having the parameter names. Another convention that you will see littered around the internet, especially on Stack Exchange or on the Esri community site, you'll see ArcPy dot, then the tool name, so Table to Excel, an underscore, and then the name of the toolbox it comes from. That would be the same for the Data Management toolbox. You'd have ArcPy dot add field underscore and management, and the same for the buffer from the Analysis toolbox. That would be ArcPy dot buffer underscore analysis. While this convention still works, I'd be reluctant to use it in case it is not future-proofed and that Esri remove this functionality in the future. They've updated all their documentation to the convention that we see here, where it's arcpy.toolboxname.toolname. An alternative is to use an alias, so we could import arcpy.conversion as C, import arcpy.management as DM for data management, and import arcpy.analysis as A. We could simply then call C.table to Excel, DM.add field, or A.buffer. It is very, very, very rare that you see this convention, and I highly recommend that you stick to the convention that we see in the documentation, and you will see this convention throughout all my videos on ArcPy. The Copy Python command option in ArcGIS Pro is a fantastic resource when you are developing your scripts, especially if you're struggling with the syntax for a geoprocessing tool or you maybe need to debug. So let's check it out. In ArcGIS Pro, I'm going to go up to the Analysis tab in the ribbon, and in the Geoprocessing group, I'm going to select Tools. I'm going to go to my toolboxes, into Analysis, into Proximity, and I'm going to open up the Buffer tool. I'm going to pick an input feature class, which will be a point feature class. I'll navigate to a file geodatabase that contains some points, and I'll pick the point feature class, click OK. I'll leave the output feature class as the default. It is going into the file geodatabase that belongs to the APRX. I'll set a distance of 100 meters, and I'll leave the method as planar and dissolve type as no dissolve. Now I do not need to run this tool. I just want to grab the ArcPy syntax. So down beside the run button, we have this arrow. I'll click it. I'm going to click on Copy Python Command. I'm now going to head over to a Python script, and I'm going to paste. And here we can see the syntax with all the named parameters. We have arcpy.analysis. It's coming from the analysis toolbox, and the tool name is buffer. The in features is the path to the feature class that I chose. The out feature class is the path to where the newly created feature class will be and the name of the feature class. The buffer distance or field, I set it to be 100 meters. And we can see the default parameters for line side, line end type, dissolve option, dissolve field, and method. So if you are ever struggling with using a geoprocessing tool with ArcPy, your best friend is to fill out the form in the GUI and then use the Copy Python command function. You can then simply paste in the ArcPy Geoprocessing tool into your script. Next up, we have the result object, and it is this result object that allows you to chain geoprocessing tools together to allow for more efficient scripting. Now, a geoprocessing tool in ArcPy will return a result object, and that result object will have what's known as derived output. And a result object can have one or more derived output. So let's check it out. The result object is the result of a geoprocessing tool. A result object maintains information about a tool operation after it has completed. This includes messages, parameters, and outputs. Now, when you're beginning ArcPy, it is the outputs that are the most important. And as you get into more advanced functionality, you might hook into the messages to check on different types of messages for tools and operations that are failing. The result object has some properties that you can tap into. We are going to check the output count to see how many derived outputs a tool generates. And we will also use one of the methods, which is the getOutput method, to access the output created from the result object. Let's put this in terms of the create feature class tool. Here we have the create feature class tool from the data management toolbox. If I scroll down and I click into the Python tab, here we can see the syntax. There are 2 required parameters and the rest are optional. But if I scroll down, we have this derived output section. Now the ArcPy documentation is fairly comprehensive when it comes to the derived output. And we can see here that we expect the create feature class tool to have one output, and that is the newly created feature class. So let's put this to test in code. Up top, I am importing ArcPy because I'm using a standalone script. And this script will resemble components of a general ArcPy workflow. So we're going to take in some user inputs. First is the out path, which is the path to an output workspace. Here I'm using a file geodatabase. And then an out name, which is the name of a feature class to create. So I'm just going to call that ArcPy created feature class _1. Let's take a look at life without the result object. Here I'm calling the create feature class geoprocessing tool. I'm supplying in the out path, the out path parameter, and the out name to the out name parameter. So the out path will be my file geodatabase, and the output name will be the ArcPy created feature class _1. Geometry type, I'm setting the point and the spatial reference to 2157. When I run this script, the create feature class geoprocessing tool is going to create a new point feature class for me. But my next step then is to add a field or multiple fields. So I'd call the ArcPy add field tool. This has an in table parameter. And you can see here I'm using string formatting to access the newly created feature class. It isn't the most efficient way to code. I'd be hard coding every time I want to chain a geoprocessing tool. Let's say I wanted to add another field. I could copy that, paste, and I'd still have this string here. And then if I add points, and then maybe I want to call the buffer tool, I'm using these string paths the whole time. Now this works just fine. If I run the tool, the script is complete. I can go over to ArcGIS Pro, into my geodatabase, and I can see that my ArcPy created feature class _1 has been created. So let's take a look where the result object comes into play, and it makes it more efficient for chaining geoprocessing tasks. I'll comment out that first example and I'll open up second. Simply by assigning the create feature class geoprocessing tool call to a variable called result or any other variable name, we will be returned a result object to our variable. Now I have variables in here for my geometry type and SRID. I'll just change those. We could of course take the geometry point and the spatial reference as user input. So after the create feature class call, I'm going to print the result to screen. I'll print the type of the result variable. We'll check how many tool outputs there are by using the result object output count property. And then for each result in our result object, we're going to use the result get output method to print each result to screen. There will be at least one result in the result object, so we can access that with indexing. And here we're just showing that we can use the result object and the get output method to retrieve the same output. So the output from our create feature class is now assigned to this result variable as a result object. And here we're using the add field tool. Our in table is now the result object. And we can also assign the calling of the add fields tool to a variable. Here I'm overwriting the result object. And once more, I will print the outputs from the add field tool to screen. I'm going to go up the top, and this time I'm going to create ArcPy created feature class _2. I'm going to run the script. The script is complete. We first printed just the result object, and we got the file path to our newly created feature class. We then printed the type of the result variable, and we can see it is a result object. Our create feature class tool had one output, and that is the path to the newly created feature class. We then used zero-based indexing from the result object to access the same feature class path, and we also used the result get output method supplying in 0 to access the first output of the result object, and that was also the path to our feature class. We then set the result object to be our add field geoprocessing tool. This also has one output, and it is the path to the input feature class that the field was added to. So I hope you can see the benefit of using the result object. In the next section of this video, we're going to take a look at the memory workspace. The result object along with the memory workspace really makes for efficient ArcPy coding and workflows. The memory workspace from ArcGIS Pro can be utilized with ArcPy. Memory workspace is a high-speed RAM-based location storage for the output of geoprocessing tools such as feature classes. Because it's not being written to disk, it is significantly faster to store those intermediate outputs from geoprocessing tools that you may not need as you perform those extract, transact and load processes on your data, and you might just want the output at the end. So let's check out the memory workspace. Here I have a linear feature class that represents the river network in Kildare in Ireland, and the dataset is from the Environmental Protection Agency. I also have another dataset, the points, and they are the National Inventory of Architectural Heritage Points from the National Built Heritage Service. My goal here is to get a subset of those points where they fall within 500 meters of a river. I also want to add a field to the subset dataset that contains an attribute that defines whether that point is within 100, 200 or 500 meters of a river. There are multiple ways to achieve the same outcome. I'm going to use the multiple ring buffer tool and create the 3 buffer zones. I'm then going to get a selection of the points that intersect those buffers, create a subset, add a field, and perform a spatial join so I can add the information for each point as to which buffer zone it intersects. Throughout this workflow, I'm going to use the memory workspace, the multiple ring buffer tool and the spatial join tool. If ran manually, you would generally output to disk. You can of course use the memory workspace now within ArcGIS Pro, but we're going to see the power of it when we are scripting. So let's head over to our Python script. For our user inputs, we have our rivers feature class, which is our Kildare rivers, and our NIAH points, which is our Kildare NIAH, and these both sit in the memory testing geodatabase. I'm going to create an output feature class named Kildare NIAH of interest that will also output to the memory testing geodatabase. I'm first going to call upon the multiple ring buffer from the analysis toolbox. We'll set our input features to be our rivers. The output feature class will be sent to the memory workspace with a name of buffer_fc. And the distances we are going to set are 100, 250, I think I said 200 earlier on, and 500. The buffer unit will be meters and the dissolve option will be all. This dissolve option means that each buffer polygon will not overlap with the previous. They will be their own individual polygons. So we'll have the output from the multiple ring buffer held in memory. I'm going to select the NIAH points that intersect the buffers. Here we call upon the select layer by location tool from the data management toolbox. Our in layer is our NIAH points, our overlap type is intersect, and our selected features is the memory buffer FC, which represents the result object from the multiple ring buffer tool. We'll assign the result object for our select layer by location tool to a variable called NIAH selection. We're now going to transfer that selection also to the memory workspace. Here we use the export features tool from the conversion toolbox. Our in features is the NIAH selection that was returned from the select layer by location tool, and our out features is in our memory workspace with a name of NIAHFC. We'll assign the result object from the export features tool to a variable called memory NIAHFC. And we're going to add a field to this feature class that's held in memory. We call the add field tool from the data management toolbox. Our in table is our memory NIAHFC. The field name we're going to create is buffer zone and the field type is text. Next, we are going to perform a spatial join that spatially joins our NIAHFC held in memory with our buffer FC also held in memory. So we use a spatial join tool from the analysis toolbox. We We set our target features to be our memory NIAHFC, the subset of the points. Our join features is the memory buffer FC, which is our buffer polygons. Our out feature class will be into the memory workspace as SJ_FC. The join operation is one-to-one. The join type is keep all, and the match option is intersect. The output from the spatial join tool will be held in memory, and we'll set the result object from that tool to memory SJFC. We now have 3 feature classes held in memory: our buffers, our points, and the result from our spatial join. It is good practice to delete from the memory workspace anything that is not needed. We are finished with our memory buffer FC, so we use the delete tool from the data management toolbox to delete that from memory, and we're also going to delete the variable from Python memory. Next, we're going to join the output from the spatial join back to our points held in memory. We use the add join tool from the data management toolbox. Our in layer or view is our points held in memory. Our in field is the object ID. This is what we're going to match from our points to the target FID field in our spatial join output. And the join type will be keep all. While those are joined, we're going to calculate the buffer zone field that we added in the memory feature class and calculate it based on the distance field from the buffered polygons. We use the calculate field tool from the data management toolbox. Our in table is our join view, which was the result object from the add join tool. The field we are updating through the calculation is our buffer zone from the NIAHFC held in memory. Our expression is going to take the distance field attribute from the spatial join and apply it to that buffer zone. We no longer have any use for the join, so we use the remove join tool from the data management toolbox to remove our join. And all we're left to do is to call the export features tool once more, where the in features is our updated memory NIAHFC and our out features is the path to our output feature class. We'll use the delete tool to remove the memory NIAHFC from memory and also the spatial join feature class, and we'll also delete those variables. Time to run the tool. We can see our print statements being added to the screen, creating multiple ring buffers, selecting the NIAH points that intersect those buffers, adding the field, performing the spatial join, calculating the buffer zone distance, removing the join and exporting from the memory to our disk. With that complete, I can head back over to ArcGIS Pro. I'm going to refresh the database. We see we have our Kildare NIAH of interest. I can add to the map. We can see here the ones that are within 500 meters and the ones that are not. And if I open up the attribute table, we can see our buffer zone attribute for each point, denoting which buffer zone it lies in. You just saw the power of the memory workspace. We have one more point to touch on, and that is the environment settings and how they affect the running of geoprocessing tools with ArcPy. So let's check it out. With ArcPy, environment properties can be used to retrieve or set current geoprocessing environment property settings. Geoprocessing environment settings affect the result from a geoprocessing tool. We're going to take a look at 2 environment setting properties, the workspace and the override output. And then I'll show you where to find more information on these and other environment settings at this link up here. For now, let's head over to ArcGIS Pro. We are in ArcGIS Pro. We go to Analysis and go to Tools. And over on the right hand side, we will search for Buffer. And we will click into the buffer from the Analysis toolbox. Here we can see the parameters, but if we click into the Environments tab, these are the environment settings that we can access with ArcPy. We have output coordinates, processing extent, parallel processing, M and Z values, and so on. Now if I click back again, and this time we're going to search for append. And this is from the data management toolbox. And we'll click into environments, and we can see that this has a different set of environments available. So individual tools will honor different environment settings. While we're in ArcGIS Pro, we'll go over to the top left and click into Project and down into Options. From the Options panel on the left, we'll choose Geoprocessing. We can also control some of these with ArcPy, most notably allowing geoprocessing tools to overwrite existing datasets. I recommend that you have this turned off and that you specifically say when you want a geoprocessing tool to overwrite an existing dataset. Another environment setting that can be accessed through ArcPy here is adding output datasets to an open map. We'll leave that checked on. Click OK, and we'll head back over to PyScripter. We're going to run the same script as we did for our memory workspace, except we're going to make some changes. Here we're setting the ArcPy.env workspace property to be our memory testing geodatabase, and this is where our feature classes reside. If I head back to the memory workspace script, you can see where we're using the full dataset paths for our rivers FC, our NIAH, and for our output. And these were all in the memory testing geodatabase. Now if we take a look at our environment settings, we are setting the workspace to be that file geodatabase. This will allow us to simply use the name of the dataset rather than the full path. We can see here rivers FC is now just Kildare Rivers. Our NIAH is Kildare NIAH, and our out feature class is going to be Kildare NIAH of interest. I also want to update the distances for the multiple layering buffer to be 100, 200, 300, 400 and 500 instead of 100, 250 and 500. Before running, I'm just going to go back over to ArcGIS Pro where I had the output from the memory workspace script open, and I'm going to remove it from the map. Now we'll go back to the script. You can see here we have arcpy.env.overwrite output set to false. What we expect to happen here is that for the whole script to run, and then when it gets to the output part of overwriting our Kildare NIAH of interest, it should fail. So let's run the script. So the script went through all the motions of creating the multiple ring buffers, selecting the points, adding them to memory, adding the field, performing the spatial join, joining, calculating the buffer zone field, removing the join, and then it tried to export from memory to disk and failed. This is because the Kildare NIAH of interest already exists. And more importantly, it failed because we had our environment setting for our overwrite output set to false. Now look what happens when I set this to true and rerun. This time the script was successful. It went through all the motions that we expected to and it exported from memory to disk, overwriting the Kildare NIAH of interest that was previously there. Let's head back over to ArcGIS Pro. I'll re-add the Kildare NIAH of interest to the map. I'll right click and open the attribute table, and we can see that our buffer zones have been updated to reflect the new workflow. So I hope you can see the power of the environment settings. We only touched on two. They are two of the most common settings you're going to set: the workspace and the overwrite output. There are plenty more. Let's head over and check out the documentation. Here we have the documentation for our environment settings, and you can access each property with dot notation after arcpy.env. You can add outputs to map, and there are a lot of environment settings here that you can use. If you're dealing with rasters, you have cell size. You can set the extent for a tool to honor. You can decide to maintain attachments or not, and so on. I would recommend taking some time reading through the environment settings and see how they can affect your workflow. One last piece of information before I finish up. Here I'm in the buffer tool from the analysis toolbox, and if I scroll down, all the way down, we will hit this environment section, and these are the environments that are honored when you run the buffer tool. And these are the environments when you're running the geoprocessing tool, not the environments from the options. The Esri documentation is a fantastic place to find out more information about what each environment can be used for each different tool. The syntax, the copy Python command, the result object, the memory workspace, and the environment settings are your 5 best friends when it comes to starting with ArcPy and geoprocessing, so make sure to take the time to learn them. I hope you found this video useful. If there's anything that needs clarification or you need further information, just leave a comment and make sure to subscribe. Take care.